Yeah, so I don't know if you guys can see my screen.
Yeah.
Yeah. So this other part of the experiment shows the results of what we end up seeing when the interpreter performs a lazy sweep. And here we just have, I think, two things to notice maybe. The total is still the same, just like before. And then when you look at the free field, we can see that we have a decrement up to some point, which is line 1. And then after that, we proceed to have another decrement. But at some point, the number shoots from 8 to 246. And then when you look at the object field, you can see that we still have an increment because we are creating new objects. Or actually, we have an increment throughout, just like before. So talking about the free field, you have on line 1, you have the value being 8, and then on line 2, you have the value being 246. And I'm quoting from the text now. The free list count drops to 8 at 1, then at 2, the free count increases to 246, but the object count remains at 104. This must be a full garbage collection, but it's not. And if Ruby had collected all available garbage objects, it would have reduced the R object count when it increased the free count, because all of our objects become garbage immediately because none of these objects are being saved as we perform this looping. So what's going on here? The results that we see in listing 12.9 describe what is called a lazy sweep, or what we've looked at before. And here we see that instead of moving all the garbage objects to the free list, we sweep only a portion of them to the free list, leaving the rest of the garbage objects in the heap that's associated with them. And because we reclaim memory for just a portion of those garbage objects, this is why we see this spike from 8 to 246. Now we'll contrast this with what happens when we do a full garbage collection. So these are the results. And here still you can see that for the total field, everything is the same. We have 17,491. And then when it comes to the free, you see that we have a consistent increment. And then when it comes to actually, it's not a consistent increment, because at some point you have the value going from 12 to 251, and then you have a decrement, after which at some point you have another increment from 181 to 9527. And then when you look at the object field, you have an increment, and then up to a some point, which is line 2, you have now a decrement from 113 to 43.
This is
So
I will note here that this is no longer how it works. This is how it used to work, but there's a different strategy now.
should we look at it if it's not the way it
Well,
works
let's
nowadays?
just skip to the next section.
Okay. The profile report and the graph.
Yeah.
Mostly the key takeaway here is that as the size of the heap increases, the time taken by the garbage collector increases as well. I think that's the key takeaway here.
Yeah. Well, yeah. Okay.
Mm,
So it's
mm,
gotten faster.
mm.
All right. So let me talk a little bit about the changes, because the section after this is going to be JRuby, which is completely different. So um okay, let me copy the link to this into chat. Sorry. Okay, so this is where my information comes from. Um, basically, um, Ruby added something called generational garbage collection. And the idea behind generational garbage collection is that uh, the things that are the objects that are old tend to stay old. The objects that are young tend to go away very, very quickly. And so you can divide up the um, the objects in your memory space into old objects and young objects. And when you do that, you get this really, really good performance benefit because you can go ahead instead of going through all of your memory. And you see that graph is linear because you're having to go through all of the memory every time. So instead, if you can skip all of the old objects and just focus on the new objects, that means uh, the amount of time it takes to just check the new objects is much, much lower. And so you have this um, you still have the old methodology of like marking and sweeping, but you're just marking and sweeping the new objects now instead of the old ones. And then the old ones can sometimes hold references to new objects. And what you don't want to do is delete those because they're being like you want to automatically move those new objects that are referenced by the old objects into the old heap and make sure that they don't get deleted because otherwise that would be a bug. Um, and there's a specific term for that that I forget right now. Yeah, I forget the term, but it basically means that like um, there's a safety lock on things that are it's called the write barrier. Uh, so the write barrier basically says uh, we're gonna demarcate like this uh, we're we're gonna everything that get referenced by the old uh, objects are automatically protected. Okay. Um, so you have this generational thing. It's still looking through the root nodes. It's still traversing those root nodes to check out everything that's referenced and seeing what is there, like what's still being used and what isn't being used. It's still marking it. So all of those things are still happening. Um, but then you just have like this other idea I that that they talked about in the book called incremental marking. And instead of doing the marking phase all at once, you do the marking phase in increments. So you just keep track of how far you get in marking, and then you just keep going. Um, so that you can reduce the amount of time you stop the world. Because remember, like the big downside to the Ruby garbage collector is stopping the world and having no code run. So you want to do it. You want to do the marking phase in increments, and that was introduced in Ruby 2.2. The sweep phase still happens, but now you have this idea of lazy sweeping that is based on the generational garbage collector. So the lazy sweeping happens for those new objects now. Uh, and so you're just basically, man, there's a there's loud noises to my right. Hopefully that's not coming through.
Yeah, I
Mhm.
don't hear it.
Okay, good. Um, then you also have this new phase called the compaction phase, which I don't think they touched on in the chapter at all. And
They
the
do.
compaction
Yeah.
phase is basically saying, okay, so after we we swept all the garbage away. What do we need to do? Well, we need to make sure that we compact all the memory together so that so that we use up less memory in total. Um, and that compaction phase has takes into account the idea of there being R values that are small R values that are large R values. So all those different sized containers get compacted uh, individually.
Yeah,
Um,
that's they show that on page 314. It actually surprised me because I would have thought the cost of having to update the references would not be worth the benefits of compacting the memory, but obviously it must be worth it or they wouldn't do it. So it must like really help a lot to compact the memory enough to where it's worth updating the references.
I think so. I mean, I think part of it has to do with like you want memory allocation is very, very expensive. So you want to avoid uh, allocating more memory. So instead, you judiciously use what you have, and that means compacting so that you can fit more things into contiguous memory. Like if you have arrays with a lot of data, you want to make sure that that data is all in a contiguous memory space. Otherwise, you're jumping around and that costs time. Um, so there's in Ruby 3.4, there's an experimental feature called MMTK, which is this effort to modularize the garbage collection. So we'll see in JRuby. JRuby has multiple different strategies for garbage collection, um, but MRI Ruby does not, and MRI Ruby wants to be able to include different strategies for garbage collection. And that's because there's always a trade-off. There's not one great garbage collector. Sometimes you have garbage collectors that are better for, smaller programs, some that use more memory, some that use less memory, but the trade-off is speed. Um, so you're always fighting um, with the trade-offs between like how much memory you're using and how much speed you're getting out of it. Um, so what they want to be able to do is they want to have the default garbage collector, and in addition to the default one, have other options for the future use. But this is experimental. It's not the default yet. Um, it's uh, it's not specific to Ruby. So MMTK is like a toolkit, memory management toolkit that can be used in other languages and for other projects. But Ruby is trying to adopt it. And the first thing they do is say, okay, we're going to separate out the Ruby code or the Ruby garbage collector into a separate space, and like gc.c is just going to be responsible for managing which memory allocator we use or garbage collector we use. Um, and like I in this chapter we talked a lot about collecting the garbage, but uh, the MMTK, like the Ruby garbage collector, is also responsible for allocating it. So the different garbage collector options hopefully will have different allocators that are better for certain things.
Are there
Um,
do you happen to know if there like do you can I guess you since it's experimental, is this controlled with like a command line flag or something? And are there already multiple garbage collectors to choose from? I guess I could look that up on my own, but I'd be happy to just if they have different garbage collector strategies or whatever, I could oh let me click on this. Cool.
Yeah.
Yeah, I'll check this out. I might like benchmark a few different options if there are new options. Oh, you have to do it when you build Ruby. I'm probably too lazy to do that. Yeah, I guess I'll probably just wait until it's not experimental then.
Yeah, I mean, it's I assume that there are like beta builds that have this
Yeah,
on.
maybe. That might be. Yeah, I definitely don't want to spend like a ton of time on it is all. But yeah, cool. Okay.
Um, okay, I have to go, guys. I have another meeting that I need to attend with
Okay.
my old boss to talk about some things.
Okay.
But I'll see you guys next week, and you guys choose a book. I really don't care. Before you
Okay.
leave this meeting, choose a book, put it in Discord, and I will read it. Okay?
Okay. Okay.
Okay. All right.
Okay. You have a good time, Nelson.
All right.